Hi, Mr. Simpson here with video for Chapter 11, Section 3, Solubility. Please take a moment to pause the video and copy down the learning objectives. As we consider the makeup of a solution, solute, dissolved, and solvent, there is a limit to how much solute will dissolve in a particular solvent under certain conditions. This is known as solubility. Solubility leads to three types of solutions. Saturated, in which we have just the amount of solute that can dissolve in the solvent under those conditions. Unsaturated, anything up to that point, as I'm dissolving solute in solvent, it would be unsaturated until we reach the limit, the saturation point. And then if I continued to add more solute, my solution would become supersaturated. There would be more solute than the solution can hold, and we would start to see precipitate forming. The extent to which that solvent dissolves, I keep referencing under certain conditions, depends on several factors. It's going to depend on the makeup of the solute and solvent molecules and those interactions between them. The temperature, how, and we're going to see in some graphs here in a second how temperature affects solubility of certain substances. And if I'm talking about gas, because many gases form solutions, and so that's going to factor in with gases as well, then pressure obviously becomes important. That leads us to a quick calculation here with Henry's law. We relate the gas solubility, as you can see there, capital CG, and the partial pressure of a gas. And those two values are directly proportional. And there is also a constant involved here, and this is specific to the gas liquid system in which we're talking about. Now, we're not going to have to look up a table for those values. We're actually going to solve for it first and then go on to solve a second part of the problem to ultimately answer our question. Here's an example of what I'm talking about. We'll walk through this one together. At 20 degrees Celsius, the concentration of dissolved oxygen in water exposed to gaseous oxygen at partial pressure of 101.3 kilopascals is 1.38 times 10 to the negative third moles. That's moles per liter, okay? Concentration moles per liter. Use Henry's law to determine the solubility of oxygen when it is partial pressure is 20.7 kilopascals. So here's where we need to first solve for K based on the information provided in the problem. So we've got our formula here, and we're going to solve for K by dividing that solubility by the partial pressure. So you can see here they give us these values in the problem here to start with. We've got a concentration listed here, and then the partial pressure listed here. So pretty straightforward calculation. Again, that's moles per liter, molarity, and then okay, and here, if I did that real quick, we would get a K value for this particular gas liquid system and temperature of 1.36 times 10 to the negative fifth, and the units there are mole per liter kilopascals. Okay, so now that I've calculated K, I can ultimately ask the question to determine the solubility of oxygen when this partial pressure is 20.7. So we'll set up our expression again. Now we know our K value. We just solved for it for this particular system. Okay, and they give us that partial pressure of 20.7 kPa. So clearly the kPa are opposite, so they'll cancel out. And I'm left with a concentration, or a 2.82 times 10 to the negative fourth moles moles per liter. Okay, so that's going to be pretty consistent with all of our Henry's Law problems. You're going to typically first have to do that calculation to get that K value for that particular system, and then use that to ultimately solve for the concentration or the partial pressure, whatever a particular problem is asking. When talking about solubility, we often think about solids dissolving in liquids, solute and solvents in that fashion, but liquids can also be both the solute and the solvent. And if two liquids mix, the term there is miscible, okay? And if two liquids do not mix, the term is immiscible. So please take a second to jot those two terms down, because they will come up when talking about solubility and mixtures with regards to two liquids. Both solute and solvents are liquids. All right, the last thing to cover in this section is a solubility chart, which looks something like this. Okay, so here you can see that I have how temperature changes affect the solubility of different solids. So if you take a look there at the labels on both axes, we have temperature across the bottom, and then solubility, grams of solute per 100 grams of water as our solubility values. Okay, so I've listed a couple common questions here that you'll see, and that we should be able to interpret this graphic and answer these types of questions. So what is the solubility of KCl at 5 degrees Celsius? I would think about a temperature at, if that's 10, that would be 5 degrees Celsius. And the formula is KCl, so the solubility of that at 5 degrees Celsius would be right here. And so, then I'm just, interpreting a graph. So if, however I decide to break up this distance between 20 and 60, we could do that and we could determine an answer there. But that's when it's asking the solubility of a certain value at a certain temperature, that's on the line. Okay, so that is those are the values at that temperature in which I have a saturated solution. So we should be able to handle those types of questions. Of course, with this level of detail, it'll be an estimation, so there may be some variation in our answers. Let's look at another one. At 90 degrees Celsius, you dissolve 10 grams of KCl in 100 grams of water. So let's think about what we have there. 90 degrees Celsius. Okay, so let's say we're right here. You dissolve 10 grams of KCl in 100 grams of water. Okay, so 10 grams of KCl would put us right about here, okay, between 0 and 20. Now the line for KCl is all the way up here, okay, and so this is the saturation line, all right? So if I only have, as you can see there, I'm well below the line of solubility for KCl. So this would clearly be an unsaturated solution. I can dissolve a lot more KCl in 100 grams of water at that particular temperature. A similar question here, so just some different examples that you can look at. You're welcome to pause the video and work through some of these. We'll also take a look at some more of these in class. Finally, questions like this: which compound is most soluble at 20 degrees Celsius? So 20 degrees Celsius, and go to the thing that is the most, that can dissolve the most at 20 degrees. So in that case, that's the sugar. Least soluble at 40. All right, so that would be right here. Questions like this are the things that we'll most commonly get as we take a look at a saturation curve. So we'll practice some more of these in our next class, but feel free to pause the video and look at some more of those questions ahead of time. All right, that wraps up our second video for Chapter 11.